Hi, and welcome to Independent Practice, Lesson 8.1. Let's get started. In art, Marie has a small copy of Rene Magritte's famous painting, The Schoolmaster. Her copy has dimensions 2 inches by 1.5 inches. The scale of the copy is 1 inch, corresponds to 40 centimeters. Find the dimensions of the original painting. Well, let's see. I'm going to start with a drawing. And that drawing will be, let's go with 2 inches by 1.5 inches. And the scale is 1 inch is 40 centimeters. 1 inch is 40 centimeters. So what I would do is I would change each measurement, the 2 inches. So let me rewrite this here. If 1 inch is 40 centimeters, then 2 inches has to be double that, 80 centimeters. Okay, and then the other one is 1.5, which would be 40 times 1.5, which I believe is 60 centimeters. See, I got that by 40 times 1.5. And so there's my dimensions. It is 80 centimeters. So we have 80 centimeters by 60 centimeters. Find the area of the original painting. Okay, well, what we'll do is we'll take our dimensions of the painting, and that means we have the 80 times 60. So it'd be 80 times 60, and 8 times 6 is 48, and then you add 2 zeros to it, so you have an area of 4,800 square centimeters. So 4,800 square centimeters. Okay, next, since 1 inch is 2.54 centimeters, find the dimensions of the original painting in inches. So each inch is 2.54 centimeters. Well, to answer this, I'm going to do a little technique that's called dimensional analysis. Let's call it dimensional analysis. Let me erase this other stuff here. I don't really need this other stuff. Oops. Yeah, I'm going to erase all this. And dimensional analysis kind of sounds something pretty scary, but let me walk you through it because it helps me when I'm trying to convert stuff and know, do I multiply by 2.54 or do I divide by 2.54? That's a big question. So let's start with what I have. I have these, oh my God. Wait, no. I was worried that I just deleted all my stuff, but I actually have it here. It was 80. I got this by multiplying, 80 by 60. So I have 80 centimeters. 80 centimeters. And I'm given 1 inch is 2.54 centimeters. So 1 inch is 2.54 centimeters. And I wrote it this way, and I can multiply this. I don't know, I just use this. Take it for what you want, but I use this to remind myself, do I multiply or divide? The reason why I set it up this way is because I want inches. I want inches to be left over. I want to know how many inches I got given 80 centimeters. And labels will cross cancel just like numbers cross cancel. So what I'm going to do is I'm going to cancel the centimeters out here. And what I'm left with is inches. See, that's the label that I want left over. Now, I did all this because now I can see that I use my regular rules for multiplying fractions. 80 times 1 is 80, and there's nothing on the bottom, so it's over 2.54. So now I can see, I need to take 80 and divide it by 2.54, and that is about 31.5 0.5 inches. I said a lot there, but that's honestly how I find out if I got to multiply or divide or whatever. So anyway, um, the 31.5 inches is the first one. So 31.5 inches. And then I'm going to do the same kind of thing, but with the 60 centimeters. So I have 60 centimeters. And I know I'm going to have to divide by 2.54. I've already established that in the previous one. So I'm just going to take that divided by 2.54. And I have 23.6. So it's by 23.6 inches. Okay, so the next one. Find the area of the original painting in square inches. Oh, that's going to be easy. That's just 30. That's just 31.5 times 23.6. 23.6 times 31.5 is 74.34. 74.34 square inches. Whoops, looks like my decimal's in the wrong spot. I was wondering what was going on there. So let me change that. 743.4. 43.4, that's a big difference, 10 times the size. Okay, next. A game room has a floor that is 120 feet by 75 feet. A scale drawing of a floor on grid paper uses 1 unit is 5 feet. What are the dimensions of the scale drawing? Okay, so let's change each of these individually. I'll bring this over here. I'll use my spot to the left. And let's go with the first one, 120 feet. So we first have 120 feet. And each unit is 5 feet. So I would divide this by 5. And 120 divided by 5, 24, I believe. So I believe it's 24. And then, so that's 24 units, 24 units. And then the other one's going to be 75 divided by 5. And I believe that is 15. So 24 units by 15 units. Next. Let's make this a little bit bigger here. So, the length of a table is 6 feet. On a scale drawing, the length is 2 inches. Write 3 possible scales for the drawing. Well, first thing I could do is I could say 2 inches corresponds to 6 feet. That's pretty easy. And then I could take half of these, half of both of them. I could say 1 inch. Really? That's inch? 1 inch is what, 3 feet? And then I could double that, and I could say double the 2, that's 4 inches, is 12 feet. So there you go. Next one, analyze the relationships. A scale for a drawing is 10 centimeters corresponds to 1 millimeter. Which is larger, the actual object or the scale drawing? Well, I believe the drawing is bigger. Oops. The drawing is bigger because 10 centimeters is bigger than 1 millimeter. See, what this is saying is each 10 centimeters represents 1 millimeter. So yeah, this is going to be a lot bigger than that. Yeah, it's shrinking this. The actual thing is smaller than your drawing. It goes from the drawing to your, anyway, I'm going to shut up now. Okay, number 10. The scale model of a building is 5.4 feet tall. Okay, if the original building is 810 meters tall, what is the scale used to make the model? Well, it looks like we have 5.4 feet corresponds to 810 meters. But what I could do is I can divide both of those by 5.4. So the first one, or probably what's more accurate, is let me do this. 5.4 divided by 5.4 is going to be 1. So I'm dividing this by 5.4, and that's going to be 1 foot. And that corresponds. Now I have to take 810 and divide it by 5.4, and that ends up being equal to 150. So that's, 150 meters. And that would be probably the better one. That's probably better. I mean, the first one's accurate, but there you go. If the model is made out of tiny bricks, each measuring 0.4 of an inch in height, how many bricks tall would the model be? Well, I think that the first thing I would do is I would figure out, first off, look at this. Look at this. This is in inches, and they give this to us in feet. We need to turn this into inches. And like I did earlier with the dimensional analysis, I need to know what 5 point, my goodness. Let's go again. 5.4 feet. And I need to turn this into inches. So that means that the inches need to be here and the feet need to be down here, so they'll cross cancel. And 1 foot is 12 inches. So, and for some of you, I might be overcomplicating this. For others of you that have no idea if you multiply or divide or whatever, this is how I decide it. Now I'll cross out my feet, and I'm left with inches. I want to know how many inches it is. And it turns out I multiply 5.4 times 12. So there you go. 5.4 times 12. That is 64.8. 64.8. I'm afraid you're going to think that this is a... There. So 64.8 inches. Okay, now I need to know how many of these little baby bricks will fit into here now that it's in inches. And the way I figured that out is division. So 64.8 divided by 0.4 is, I believe that's 132. So 132 bricks. Okay, next page. Let's see what we got here. Number 11, you have been asked to build a scale model of your school out of toothpicks. Imagine your school is 30 feet tall and your scale is 1 foot. Each foot represents 1.26 centimeters. Okay. If a toothpick is 6.3 centimeters tall, how many toothpicks tall will your model be? Well, let's find out. Well, first, how many centimeters tall is it? Well, if we use this information here, each foot is 1.26 centimeters. So, and we use this idea that it's 30 feet tall. Each foot is 1.26 centimeters. So that means that we would have to take 30 feet, or that 30 times 1.26, and 30 times 1.26 is 37.8. And then each one is 6.3 centimeters tall. And that's how many, so this is 37.8 centimeters. That's how tall the thing is. And now each toothpick is 6.3. So we would take 37.8 divided by 6.3. and divided by 6.3, and that is 6, so it'd be 6 toothpicks tall. Okay, your mother's out of toothpicks and suggests that you use cotton swabs instead. You measure them and they were 7.6 centimeters tall. How many cotton swabs tall will your model be? Okay, so we got to switch it out. Thanks, Mom. So 37.8 divided by this time 7.6. So 37.8 divided by 7.6 is 4.97. And so we're gonna have to. We should probably round that because we gotta. So about 5 toothpicks tall. Next. All right, drawing conclusions. The area of a square floor on a scale drawing is 100 square centimeters, and the scale of the drawing is 1 centimeter corresponds to 2 feet. What is the actual area of the floor? What is the ratio of the area of the drawing to the actual area? Okay, it looks like I'm going to have to draw something here. So, square floor. Square floor, it's 100 square centimeters. That means it has to be 10 by 10 because 10 times 10 is 100, and it's a square. Both sides have to be the same length. So it's 10 centimeters, and this is 10 centimeters. Okay, I'm going to erase this part here. Now, each centimeter is 2 feet. So that's 10 centimeters. So that means this is going to be 20 feet, right? And this is going to be 20 feet. How did I get that? Well, I used this statement right here. Each centimeter is 2 feet, so 10 centimeters has to be 2 times 10, which is 20. Okay. What's the area of the actual floor? It would be 20 times 20. 20 times 20, which is 400 square feet. So it'd be 400. Okay, so 400 square feet. What's the ratio of the area of the drawing to the actual area? So the area of the drawing is 100, 2, and the actual one was 400. So that is equal to 1/4. I'm just trying to decide on a color. 1/4. And yeah, so what's the ratio of the area? It's 1 to 4. So the ratio is 1 square centimeter corresponds to 4 square feet. Describe how to redraw the scale drawing with a new scale. All right, I had a lot to write. I had a lot to write there, and I thought it'd be better if I just wrote it and let you see here. We could decide on a new scale you like to use, then you use the ratio between the old scale and the new scale and redraw accordingly. For example, the ratio could be 1 to 3. And in this case, you would redraw the dimensions at 3 times the size of the original size. See, 1, and then that's 3 times the size of the original size. Okay, let's go into our last question. The scale drawing of a room is drawn on a grid that represents a 1/4 inch grid paper. The scale is 1/4 inch is equal to 4 feet. Redraw the scale drawing of the same room using a different scale. What scale did you use, and what is the length and width of the actual room? What is the area of the actual room? All right, so what we can use is a new scale of 1/4. Each 1/4 inch is now going to be 8 feet instead of 4 feet. So let's see now. Let's look at our original here. in this right here, each quarter inch is 4 feet. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 of them, but each of them, it represents 4 feet. So let's multiply that by 4, and that means we have represented 40 feet. Okay, we need to represent 40 feet in the other one as well. So if each one is 8 feet, oh, we just need to cover 40 feet. So this would be, if I did this, that's 8 feet. And then this would be another 8, which is 16. And then 8 times 3 is 24. And 8 times 4 is 32. And 8 times 5 is 40. So this is, again, 40 feet. But our new scale is I'm using this, each quarter inch is representing 8 feet. So 8 times 1, 2, 3, 4, 5 is 40. Now the other side, and notice here, this is 5, 1, 2, 3, 4, 5, and this is 10. So this is going to be half the size of this because each square represents twice as much space. And now I can go 1, 2, 3, 4, 5, 6. So that means this just has to be 3. 1, 2, 3. Finish this off. What is this? Each quarter inch represents 4 feet. So 1, 2, 3, 4, 5, 6. So that means this has to be 24 feet, and this still is 24 feet, but just a different scale. Okay, there's a scale I use. What is the length and width of the actual room? Well, length is 40 feet. Width is 24 feet. And what is the area of the actual room? Area is, well, area, okay, let's not get crazy now. Area is length times width, which is 40 times 24. 40 times 24 is 960. So the area is 960, and feet, that's all in feet, so square feet. There you go. That's what you got to know about all this stuff in the independent practice. I hope this has been helpful. Bye.